Few landscapes on Earth preserve human activity as completely as the hyperarid plains of southern Peru. Stretching between the Pacific coastline and the western slopes of the Andes, the Nazca Desert forms one of the driest environments on the planet. Annual rainfall in much of the region averages less than 25 millimeters, with some years receiving no measurable precipitation at all. This extreme aridity has remained largely stable for millennia, creating environmental conditions uniquely suited to long-term preservation of surface features. The Nazca Desert occupies a broad plateau approximately 400 to 600 meters above sea level, bounded by the coastal Cordillera to the west and the Andean foothills to the east. This position isolates the region from moisture-bearing weather systems. The cold Humboldt Current suppresses evaporation along the coast, while the Andes block humid air masses from the Amazon basin. As a result, cloud cover is limited, winds are relatively mild, and temperature fluctuations remain moderate throughout the year. Geologically, the desert surface is characterized by what archaeologists describe as desert pavement. Over thousands of years, wind erosion has removed finer sediments, leaving behind a compact layer of dark, iron oxide-coated stones. Beneath this surface lies lighter-colored subsoil composed of clay, sand, and gypsum-rich sediments. When the surface stones are displaced, the contrast between dark and light material becomes immediately visible. This geological structure made large-scale ground markings both feasible and durable using simple tools and coordinated labor. Wind patterns in the Nazca region further contributed to preservation. Prevailing winds are generally weak and consistent in direction, reducing the redistribution of surface stones once displaced. Unlike dune-based deserts, the Nazca Plains experience minimal sand accumulation. Archaeological sediment studies indicate that many exposed surfaces have remained largely undisturbed since the late Holocene, allowing geoglyphs to persist for centuries without significant erosion. Despite the desert's severity, life in the region has always depended on water descending from the Andes. The Nazca and Ingenio rivers originate in highland rainfall zones and flow seasonally toward the coast, cutting narrow green corridors through the arid plain. Archaeological surveys show that human settlement clustered almost exclusively along these river valleys, where alluvial soils supported agriculture. Outside these corridors, permanent habitation was virtually impossible. Radiocarbon dating of early habitation sites along the Nazca River indicates continuous human presence in the region from at least 2000 BCE. Sediment cores taken from valley floodplains demonstrate long-term environmental stability, with no evidence of major climatic shifts until much later in the first millennium CE. This continuity allowed cultural practices to develop incrementally, shaped by predictable environmental constraints rather than sudden ecological disruption. The river valleys also functioned as natural conduits between the coast and the highlands. Archaeologists have identified pathways linking valley settlements to upland resource zones, facilitating the exchange of goods such as obsidian, pigments, and textiles. These routes would later become embedded within ritual landscapes, though their origins were practical rather than ceremonial. Water availability remained seasonal and variable, requiring careful management. Even in periods of relative climatic stability, river flow fluctuated annually. Early communities adapted by settling near floodplains, constructing small-scale irrigation channels, and timing agricultural cycles to seasonal runoff. Archaeobotanical remains indicate the cultivation of maize, beans, squash, and cotton, crops well suited to controlled irrigation in arid environments. The desert beyond the river valleys was not agriculturally productive, yet it remained visually and symbolically prominent. Its vast, open surfaces provided uninterrupted sight lines extending for kilometers. From ground level, slight elevations offered expansive views across the plain, while the uniform terrain allowed straight lines to be laid out with minimal obstruction. Archaeological mapping confirms that many geoglyphs were placed on gently sloping ground adjacent to valleys rather than within them, positioning ritual activity in deliberate contrast to daily subsistence zones. Importantly, there is no evidence that the Nazca Desert experienced significant soil displacement, tectonic uplift, or catastrophic flooding during the primary period of geoglyph construction between roughly 100 BCE and 650 CE. This environmental consistency explains why lines created by removing stones only 10 to 15 centimeters deep could remain intact for centuries. Preservation was not the result of maintenance, but of environmental stability. By the end of the first millennium BCE, human communities along Peru's southern coast had fully adapted to the constraints and opportunities of this landscape. Settlement, agriculture, and movement were tightly bound to river systems, while the surrounding desert remained open, stable, and visually dominant. These environmental conditions formed the physical foundation upon which localized cultural traditions would develop in the centuries that followed. Before continuing, consider subscribing to the channel and enabling notifications to receive future Nightfall documentaries. If you find a particular section especially informative, you're welcome to note it in the comments. Long before the first geoglyphs appeared, symbolic expression already shaped the desert floor. The cultural foundations of the Nazca tradition emerged gradually from earlier societies that occupied Peru's southern coast, most notably the Paracas culture, which flourished between approximately 800 BCE and 100 BCE. Archaeological evidence indicates that Paracas communities developed complex ritual practices, artistic conventions, and landscape engagement that would later influence Nazca cultural forms. The Paracas culture occupied a broad region, extending from the Ica Valley to the Paracas Peninsula and inland foothills. Settlement patterns reveal small communities clustered near river valleys and coastal resources, similar to later Nazca habitation. These communities relied on irrigation agriculture, fishing, and regional exchange networks. Archaeological continuity in subsistence strategies suggests long-term adaptation to the same environmental constraints that later shaped Nazca society. Paracas is best known for its sophisticated textile production. Excavations at sites such as Paracas Cavernas and Paracas Necropolis have uncovered burial bundles containing elaborately woven textiles, some exceeding 300 threads per inch. These textiles display complex iconography, including anthropomorphic figures, stylized animals, and supernatural beings rendered in vivid colors. The technical skill and symbolic consistency evident in Paracas textiles indicate a well-established visual language used to convey religious and social meaning. Burial practices provide additional insight into Paracas belief systems. Individuals were interred in subterranean chambers or shaft tombs, often wrapped in multiple layers of textiles and accompanied by offerings. The presence of grave goods and the careful treatment of the dead suggest concepts of ancestry, ritual continuity, and social differentiation. Cranial modification, achieved through deliberate shaping during infancy, is frequently observed in Paracas skeletal remains. This practice likely functioned as a visible marker of identity or group affiliation rather than a sign of political authority. Paracas iconography exhibits motifs that later appear in Nazca ceramics and geoglyph imagery. Archaeologists have identified recurring representations of birds, felines, serpentine forms, and masked figures across Paracas material culture. While stylistic execution differs, the persistence of these motifs suggests symbolic continuity across cultural phases. Ceramic analysis shows a gradual transition from Paracas-influenced styles to distinctly Nazca forms rather than an abrupt break. Evidence of early ritual engagement with the landscape appears during the Paracas period, though on a smaller and less formalized scale than later Nazca geoglyphs. Archaeologists have documented cleared areas, linear alignments, and modified hilltops associated with Paracas sites. These features are not comparable in size or complexity to the Nazca Lines, but they demonstrate an emerging pattern of marking and organizing space beyond immediate habitation zones. Importantly, there is no conclusive evidence that Paracas populations created the Nazca geoglyphs themselves. Radiocarbon dating of wooden stakes used in Nazca Lines consistently places large-scale geoglyph construction after 100 BCE, corresponding to the early Nazca period. While Paracas traditions influenced later practices, the technological execution and spatial scale of the Nazca Lines represent a distinct cultural development rather than a direct continuation. The transition from Paracas to Nazca culture was gradual and regionally varied. Archaeological layers show overlapping ceramic styles, shared burial customs, and continued use of established settlements. Rather than collapse or replacement, the evidence supports a process of cultural transformation driven by internal adaptation. As populations reorganized along river valleys, new religious centers emerged, most notably Kawachi, which would later become central to Nazca ritual life. This transformation also involved shifts in artistic emphasis. While Paracas textiles remained highly complex, Nazca culture increasingly expressed symbolic imagery through ceramics and landscape modification. This change reflects evolving ritual priorities rather than technological loss. Materials, techniques, and motifs were selectively adapted to new cultural contexts. By the end of the 1st century BCE, Paracas cultural forms had largely given way to a distinct Nazca identity. The foundations laid by earlier societies, symbolic imagery, ritualized burial practices, landscape awareness, and environmental adaptation, remained embedded in this new cultural expression. These inherited traditions provided the conceptual framework upon which Nazca society would develop its most distinctive features in the centuries that followed. The Nazca Lines were never lost, only misunderstood. Long before modern researchers documented the geoglyphs, the markings of Peru's southern desert were known to the people who lived among them. Indigenous communities occupying the Nazca and Ingenio valleys were fully aware of the lines and cleared surfaces that crossed the surrounding plains. These features were visible from the ground, integrated into local movement across the landscape, and did not require rediscovery in any meaningful sense. When Spanish expeditions entered the region in the 16th century, they encountered a landscape already shaped by centuries of human activity. Early colonial chroniclers recorded the presence of straight lines and cleared tracks extending across the desert, though they did not assign them particular symbolic importance. The most frequently cited account appears in the writings of Pedro Cieza de Leon, who traveled extensively through Peru in the 1540s. In his Crónica del Perú, Cieza de Leon noted long lines in the desert near Nazca, describing them as markers or roads visible across the plain. These early descriptions are brief and observational rather than analytical. Colonial writers were primarily concerned with resources, settlements, and administrative control. Features that did not fit into familiar European categories of infrastructure or architecture received limited attention. As a result, the lines were often interpreted as caminos reales, boundary markers, or remnants of pre-Hispanic roads. There is no indication that Spanish chroniclers viewed them as ceremonial constructions or attributed them to astronomical or symbolic purposes. Importantly, colonial sources do not suggest that the lines were mysterious or hidden. They were clearly visible at ground level, particularly the long straight lines and trapezoidal forms that intersected established travel routes. Local populations continued to move across the desert using paths that sometimes coincided with ancient markings. In this context, the lines functioned as part of a lived landscape rather than as isolated monuments. The absence of detailed colonial interpretation reflects limitations of perspective rather than absence of awareness. Without aerial observation, the full scale and figurative forms of the geoglyphs were not easily recognized. Biomorphic figures such as birds and animals are difficult to perceive from ground level, especially when encountered in fragments rather than as complete compositions. As a result, early observers recorded what they could see and understand within their own experiential framework. There is also no evidence that indigenous communities attempted to explain the lines to colonial authorities in symbolic or ritual terms. By the 16th century, the Nazca culture had long ceased to exist as a distinct social entity, and subsequent populations did not maintain the ritual systems that had given the lines their original meaning. Oral traditions connected specifically to geoglyph creation do not appear in surviving records. This absence should not be interpreted as deliberate concealment, but rather as the result of cultural transformation over several centuries. Colonial neglect of the Nazca lines continued into the early Republican period. Travelers, surveyors, and local administrators occasionally mentioned desert markings, but none undertook systematic study. The lines were neither destroyed nor preserved intentionally. Their survival depended almost entirely on environmental stability. In some cases, colonial roads and later rail lines crossed the desert without recognizing the significance of the markings beneath them. The concept of discovery, applied to the Nazca lines, is therefore a retrospective construction. It reflects the moment when scholars began to document, map, and analyze the geoglyphs within a scientific framework, not the moment when they first became known. Indigenous familiarity and colonial observation preceded modern research by centuries, even if those encounters lacked interpretation. By the late 19th century, interest in Peru's pre-Hispanic past increased, but the Nazca Desert remained peripheral to archaeological investigation. Its apparent emptiness and lack of monumental architecture limited scholarly attention. It was only with the advent of new modes of observation in the 20th century that the lines would be understood as part of a coherent and extensive system. Flight transformed scattered lines into a coherent system. During the early decades of the 20th century, technological changes in transportation fundamentally altered how the Nazca Desert was perceived. The expansion of commercial aviation along Peru's southern coast in the 1920s provided observers with an elevated perspective unavailable to earlier travelers. From the air, long straight lines, trapezoidal shapes, and intersecting pathways appeared not as isolated features but as parts of a vast, organized landscape. One of the first scholars to recognize the archaeological significance of these markings was the Peruvian archaeologist Toribio Mejia Zesp. In 1927, while conducting fieldwork in the Nazca region, Mejia Zesp documented linear features extending across the desert plains. He presented his observations in 1939 at the International Congress of Americanists in Lima, arguing that the lines represented ancient ceremonial pathways rather than roads. His work marked the first systematic academic attempt to interpret the geoglyphs within a cultural framework, although it initially received limited international attention. Around the same time, American historian Paul Kosak began investigating pre-Hispanic irrigation systems in southern Peru. While surveying ancient canals in the Nazca valleys in the late 1930s, Kosak observed desert markings from the air and recognized their scale and complexity. Unlike earlier observers, Kosak approached the lines as an integrated system. Through aerial photography and ground verification, he identified dozens of lines converging toward specific points on the horizon. Kosak proposed that some of the lines aligned with solar events, notably the winter solstice sunset. In 1941, he described the Nazca Desert as the largest astronomy book in the world, suggesting that the geoglyphs functioned as a calendrical or astronomical system. While later research would challenge the extent of these claims, Kosak's work was influential in framing the lines as intentional, large-scale constructions requiring planning and coordination. Maria Reich, a German-born mathematician and linguist living in Peru, became the most dedicated and influential figure in early Nazca research. Beginning in the early 1940s, Reich collaborated with Kosak and later continued the work independently. Over several decades, she mapped hundreds of lines and figures using ground measurements, surveying tools, and aerial photographs. Her meticulous documentation established the first comprehensive inventory of the geoglyphs. Reich emphasized precise measurement and geometric analysis. She recorded line lengths, orientations, and intersections, producing detailed maps that revealed recurring patterns across the desert. Her work demonstrated that the geoglyphs were not randomly distributed but followed consistent spatial logic. Reich also identified numerous biomorphic figures, including birds, mammals, and abstract shapes, many of which were previously unrecognized. In addition to documentation, Reich played a crucial role in preservation. At a time when the Nazca Lines faced increasing threats from road construction and agricultural expansion, she actively advocated for their protection. She lobbied Peruvian authorities, monitored damage, and even personally cleared debris from the lines. Her efforts contributed directly to the recognition of the Nazca Lines as a site of national and later international importance. Methodologically, mid-20th century research marked a transition from descriptive observation to analytical archaeology. Aerial photography allowed scholars to examine large-scale spatial relationships, while ground surveys verified construction techniques and surface modification. Radiocarbon dating of wooden stakes found at line intersections provided the first secure chronological framework, placing major construction phases between approximately 100 BCE and 650 CE. These methodological advances also imposed limits on interpretation. As more data accumulated, it became clear that not all lines aligned with astronomical events. Statistical analysis showed that many orientations occurred by chance, reducing support for purely astronomical explanations. This shift reflected a broader trend toward evidence-based interpretation and away from singular explanatory models. By the late 20th century, Nazca research had become increasingly interdisciplinary. Archaeologists, geologists, climatologists, and geospatial analysts contributed to a more nuanced understanding of the lines as part of a ritual landscape shaped by environmental, social, and religious factors. The work of early researchers provided the empirical foundation upon which later interpretations would build. Documentation raised deeper questions about authorship and purpose. With the scale, chronology, and distribution of the Nazca Lines now established, scholars turned toward understanding why such extensive landscape modification occurred and how it functioned within Nazca society. The lines required precision, not advanced technology. The Nazca geoglyphs were created through straightforward yet deliberate methods that relied on environmental knowledge, careful planning, and coordinated labor rather than complex tools or engineering systems. Archaeological investigation has shown that the physical construction of the lines was well within the technological capabilities of the Nazca people. The most common geoglyph form consists of long straight lines, some extending several kilometers across the desert plain. These lines vary in width, typically ranging from 1 to 4 meters. Construction involved removing the dark, iron oxide-coated surface stones and exposing the lighter sediment beneath. Measurements taken across multiple sites show that the cleared depth rarely exceeds 10 to 15 centimeters. This shallow removal was sufficient to create strong visual contrast while minimizing labor investment. Trapezoidal forms represent another major category of Nazca geoglyphs. These shapes consist of broad, flattened areas that widen toward one end and are often connected to straight lines. Archaeological mapping indicates that trapezoids were constructed by clearing large contiguous surfaces rather than outlining shapes alone. Their scale suggests sustained collective effort, though excavation profiles confirm uniform depth and consistent technique across different sites and periods. Spiral and curvilinear forms appear less frequently but demonstrate the same construction principles. Spirals were created by continuous stone removal along a curved path, maintaining consistent width and spacing. These figures indicate controlled movement during construction, as deviations would have been immediately visible on the uniform desert surface. Experimental reconstructions show that a small team using wooden stakes and ropes could maintain curvature accuracy over long distances. Biomorphic geoglyphs, depicting animals, plants, and abstract figures, are among the most visually complex forms. These include representations of birds, monkeys, spiders, and stylized human figures. Despite their complexity, excavation and surface analysis reveal no difference in construction method compared to linear designs. Outlines were created by clearing stones along predefined paths, with interior areas left untouched. Variations in line width and curvature suggest adjustment during construction rather than execution from a fixed template. Archaeologists have identified wooden stakes embedded at key points along some geoglyphs, particularly at intersections and corners. Radiocarbon dating of these stakes provides direct evidence for construction periods, clustering primarily between approximately 100 BCE and 650 CE. The stakes likely served as reference markers to maintain alignment and proportion. Their presence confirms intentional layout rather than improvised marking. Experimental archaeology has played a central role in understanding construction feasibility. Controlled experiments conducted by researchers have demonstrated that small groups, sometimes as few as 5 to 10 individuals, could produce hundreds of meters of straight line within a single day using simple tools. Wooden digging implements, stone scrapers, and baskets for clearing debris were sufficient. No evidence of metal tools or advanced surveying instruments has been found in association with the lines. Accuracy in line orientation did not require aerial oversight. Ground-based techniques such as sighting along fixed points, using horizon markers, or aligning stakes across open terrain were effective in maintaining straightness over long distances. Studies comparing Nazca line alignment with topographic features indicate frequent reference to hills, ridges, and valley edges. These natural landmarks provided stable visual guides during construction. The Nazca Desert itself facilitated precision. The absence of vegetation and minimal surface disturbance meant that once a line was laid out, its path remained visible throughout construction. Unlike forested or sandy environments, errors did not require correction through excavation or rebuilding. The surface conditions allowed incremental progress while preserving orientation. Importantly, there is no evidence that the Nazca attempted to conceal construction processes. Tool marks, displaced stone piles, and construction overlaps remain visible in many locations. This transparency suggests that the act of making the lines was not hidden or restricted, reinforcing interpretations of communal rather than elite-directed activity. The diversity of geoglyph types also reflects chronological variation. Archaeological sequencing indicates that early Nazca phases favored straight lines and trapezoids, while later periods introduced more biomorphic figures. This progression suggests evolving ritual or symbolic priorities rather than changes in construction capability. The underlying technique remained consistent across centuries. Construction did not significantly alter the subsurface or damage the desert ecosystem. Because stones were displaced rather than removed entirely, materials remained nearby, and erosion was minimal. This low-impact approach contributed to long-term preservation and reflects an understanding of environmental conditions. Overall, the physical construction of the Nazca Lines demonstrates that large-scale landscape modification can be achieved through simple means when environmental conditions, collective labor, and planning align. The techniques used required coordination and intent but did not depend on technological innovation beyond what was already present in Nazca society. Construction implies planning and coordination. The consistent execution of diverse geoglyph forms across vast areas indicates that organization extended beyond individual effort, pointing toward broader social mechanisms that governed how labor was mobilized and directed across the Nazca landscape. These were collective acts, not monumental commands. Archaeological evidence indicates that the creation of the Nazca Lines relied on communal labor systems rather than centralized, coercive authority. The scale of the geoglyphs suggests coordination, yet the social structure of Nazca society does not support the presence of a ruling elite capable of mobilizing large workforces through force or taxation. Settlement archaeology across the Nazca and Ingenio River valleys reveals a dispersed pattern of habitation. Villages were relatively small, composed of domestic compounds rather than administrative centers or fortified hubs. Excavations have not uncovered palaces, monumental state architecture, or bureaucratic facilities comparable to those seen in later Andean polities. This absence supports interpretations of a segmentary or corporate social organization rather than a hierarchical state. Labor organization is best understood through analogies with known Andean communal systems. Ethno-historic sources from later periods describe practices such as Aini, reciprocal labor, and Minka, community service, where households contributed labor for shared projects without permanent stratification. While direct textual evidence from the Nazca period is unavailable, settlement patterns and material culture suggest similar cooperative frameworks. Seasonality played a critical role in workforce availability. Agricultural production along the south coast depended on river-fed irrigation systems, with labor demands peaking during planting and harvest cycles. Archaeologists note that geoglyph construction likely occurred during periods of reduced agricultural activity, when surplus labor could be redirected toward communal or ritual tasks. This seasonal rhythm aligns with the absence of permanent construction camps or worker housing near the lines. Planning did not require centralized administration but did demand shared conventions. The repetition of standardized forms, straight lines, trapezoids, and consistent line widths, indicates common rules governing construction. These conventions were likely maintained through cultural transmission rather than formal oversight. The use of stakes and alignment points suggests coordination among participants, but not necessarily top-down control. Archaeological surveys show that many geoglyphs are connected to pathways leading from habitation zones towards ceremonial areas. These paths exhibit similar construction techniques and wear patterns, indicating regular movement by groups rather than episodic mass mobilizations. The integration of lines into everyday movement patterns supports the interpretation of gradual, collective construction over time. Importantly, there is no evidence for social differentiation among participants. Burials associated with Nazca settlements do not show stark inequalities in grave goods that would imply a laboring class versus an elite class. Textile quality, ceramic distribution, and housing size remain relatively consistent across sites. This material homogeneity suggests that participation in large-scale projects was broadly shared within the community. The absence of defensive structures also informs interpretations of labor organization. Nazca settlements lack fortifications or signs of internal conflict that might necessitate enforced labor extraction. Instead, social cohesion appears to have been maintained through shared ritual practices and regional identity. The lines themselves may have functioned as reinforcing symbols of that cohesion. Radiocarbon dating indicates that geoglyph construction occurred over several centuries rather than during a single intensive building phase. This temporal spread supports a model of incremental labor investment. Small groups could add new lines, extend existing ones, or maintain cleared surfaces across generations. Such continuity requires social agreement and cultural importance but not centralized direction. Archaeologists have also noted overlaps and intersections among lines, suggesting that construction was not governed by rigid master plans. Instead, new designs were added in relation to existing features, adapting to an evolving landscape. This flexibility further argues against authoritarian planning and in favor of negotiated communal decision-making. The labor required to construct the Nazca Lines was therefore substantial but not extraordinary within its social context. It relied on predictable participation, shared knowledge, and environmental familiarity. Rather than serving economic or defensive functions, the mobilization of labor appears to have been embedded within broader cultural and ceremonial practices. Such labor was likely ritualized rather than utilitarian. The organization and repetition of effort across generations point toward motivations rooted in belief systems and social integration, which shaped how work, meaning, and landscape were interconnected within Nazca society. For the Nazca, the desert was not barren, it was sacred terrain. Archaeological and iconographic evidence indicates that Nazca cosmology understood the landscape as an active participant in religious life rather than a passive backdrop. This worldview developed between approximately 100 BCE and 400 CE, paralleling the expansion of geoglyph construction across the southern Peruvian coast. Nazca religious beliefs are reconstructed primarily through ceramics, textiles, and architectural remains, as no written records survive. Painted vessels frequently depict supernatural beings, ritual scenes, and transformed human figures, suggesting a cosmology grounded in animism and spiritual mediation. Animals, plants, humans, and natural forces appear interconnected, implying that spiritual power permeated the environment rather than residing in distant deities. One of the most prominent figures in Nazca iconography is the so-called anthropomorphic mythical being. This composite entity, combining human traits with features of animals such as felines, birds, or serpents, appears repeatedly on ceramics and textiles. Archaeologists interpret this figure not as a single god but as a visual expression of transformation, fertility, and cosmic balance. Its recurrence suggests shared religious concepts across communities rather than localized cults. Ancestor veneration also appears to have played a central role. Trophy heads, human heads modified with drilled holes and cords, are depicted frequently in Nazca art and recovered from ritual contexts. While earlier interpretations emphasized warfare, more recent studies associate these objects with fertility rites, agricultural cycles, and ancestral power. Their presence reinforces the idea that the living and the dead were connected through ritual practice embedded in the landscape. The desert itself held symbolic importance within this belief system. Rather than being perceived as empty or marginal, the pampa functioned as a liminal zone between inhabited valleys and the supernatural realm. The physical act of modifying the desert surface, clearing stones, exposing lighter soil, and maintaining visibility, can be interpreted as a form of ritual engagement with sacred space. Records indicate that geoglyph placement often aligns with natural features such as hills, valleys, and water sources, reinforcing their cosmological significance. Excavations at Kawachi, the largest known Nazca ceremonial center, provide further insight into this worldview. Located near the Nazca River but not within a dense residential zone, Kawachi lacks evidence of permanent urban occupation. Instead, archaeologists uncovered plazas, platforms, and ritual deposits, including broken ceramics, textiles, and organic offerings. These findings suggest episodic pilgrimage and ceremonial use rather than continuous habitation. The relationship between Kawachi and the surrounding geoglyphs has been central to scholarly interpretation. Many lines and trapezoids radiate toward the ceremonial center, implying intentional spatial integration. According to archaeological surveys, this arrangement indicates that ritual movement across the desert was a meaningful religious act, connecting distant communities to shared sacred locations. Comparative analysis with broader Andean cosmological models supports these interpretations. Later Andean societies, including the Inca, conceptualized the world as a living system structured through reciprocal relationships among humans, ancestors, and natural forces. Mountains, rivers, and plains were imbued with spiritual agency. While direct continuity cannot be assumed, similarities suggest long-standing regional traditions rather than isolated ideological development. Chronological evidence supports the emergence of this cosmology alongside Nazca cultural consolidation. Radiocarbon dating of ceramics and architectural phases at Kawachi places peak ceremonial activity between 200 BCE and 300 CE. This timeframe overlaps closely with the most intensive period of geoglyph creation, reinforcing interpretations that the lines functioned within a broader religious framework rather than serving singular or utilitarian purposes. Importantly, Nazca cosmology does not appear to have emphasized centralized priestly authority. Ritual knowledge was likely distributed across communities, transmitted through shared visual language and collective participation. The uniformity of iconographic themes across a wide region suggests cultural coherence without strict institutional control. Archaeologists uncovered no evidence of temples designed for exclusive access or restricted ritual specialists. Instead, open plazas and expansive desert spaces indicate inclusive ceremonial practices. This openness aligns with interpretations of the landscape itself as the primary ritual medium, accessible through movement, visibility, and participation. This worldview shaped how ritual activity was physically expressed across the land. The Nazca did not merely inhabit their environment. They structured belief, identity, and social cohesion through direct engagement with the desert, establishing a sacred geography that would define their cultural legacy for centuries. These lines were meant to be walked. Archaeological analysis increasingly supports the interpretation of many Nazca geoglyphs not as images designed primarily for visual display, but as pathways structured for repeated human movement across the desert surface. This perspective shifts emphasis from symbolic representation alone to embodied ritual practice carried out within the landscape itself. Several physical characteristics of the lines support this interpretation. Many linear geoglyphs are wide enough to accommodate groups of people walking side by side, often measuring between 1 and 4 meters in width. Their surfaces are uniformly cleared of darker stones, exposing compacted, lighter soil beneath. Archaeologists note that this exposed surface shows signs of sustained compression rather than a single episode of disturbance, consistent with repeated foot traffic over extended periods. Directional consistency further reinforces the pathway model. Long straight lines frequently maintain precise orientation over several kilometers, cutting across slopes and shallow depressions without deviation. Such persistence suggests intentional alignment rather than casual marking. Surveys indicate that these alignments often correspond to routes linking habitation areas in the river valleys with ceremonial zones on the desert pampa. The spatial relationship between the geoglyphs and Kawachi is particularly significant. Many trapezoids and linear pathways appear to converge toward the ceremonial center or toward natural features adjacent to it. Excavations at Kawachi reveal no evidence of permanent residential populations during peak use, reinforcing interpretations of the site as a pilgrimage destination rather than an urban center. The lines may have structured ritual journeys toward this focal point. Chronological sequencing supports an evolving system of movement-based ritual. Early Nazca geoglyphs, dating to the late Paracas and early Nazca phases, tend to be simpler and more localized. During the Middle Nazca phase, approximately 200 to 450 CE, the number and complexity of pathways increase markedly. Radiocarbon dating and ceramic associations indicate sustained investment in expanding and maintaining these routes during this period. Where pattern analysis conducted along select lines shows uneven erosion consistent with directional movement. In some cases, the edges of pathways are more pronounced than central areas, suggesting repeated traversal rather than symbolic clearing alone. Experimental archaeology has demonstrated that even moderate foot traffic can maintain such surfaces over centuries under hyperarid conditions. Importantly, the pathways do not function as transportation routes in an economic sense. They do not optimize travel efficiency, avoid obstacles, or connect resource zones. Instead, many routes deliberately extend across open desert, sometimes terminating at points with no obvious utilitarian function. This pattern aligns more closely with ritual procession than with trade or communication networks. Ethnographic parallels from later Andean societies provide interpretive context. Colonial-era sources describe pilgrimage routes leading to huacas, sacred places associated with ancestors, water, or fertility. Movement itself was considered a ritual act, reinforcing social bonds and cosmological order. While these sources postdate the Nazca by many centuries, they suggest long-standing Andean traditions linking walking, ritual obligation, and sacred geography. Nazca iconography supports this movement-centered interpretation. Ceramics frequently depict figures in procession, often holding ritual objects or moving in coordinated groups. These scenes emphasize motion rather than static worship, reinforcing the idea that religious practice unfolded through action across space. Archaeologists have also noted the absence of viewing platforms or elevated observation points associated with most geoglyphs. This absence undermines interpretations that prioritize aerial visibility as the primary function. Instead, the scale and orientation of many lines are best understood from ground level, experienced sequentially rather than all at once. The process of walking these pathways may have structured time as well as space. Seasonal pilgrimages tied to agricultural cycles, water availability, or calendrical events would have reinforced communal rhythms. Such practices could integrate dispersed communities across the Nazca region without requiring centralized political authority. Not all geoglyphs functioned as pathways, and scholars caution against overly uniform interpretations. However, the prevalence of walkable lines, combined with wear patterns and spatial organization, indicates that movement was a central component of their use. The desert surface became a medium through which ritual was enacted, remembered, and renewed. Movement through the landscape was closely tied to symbolic imagery. As participants traversed these pathways, they engaged not only with the physical environment but also with the visual forms and sacred meanings embedded within it, linking bodily action to the broader religious system of Nazca society. Water scarcity shaped every aspect of Nazca life. The south coast of Peru is among the most arid regions on Earth, defined by minimal precipitation, high evapotranspiration, and strong climatic variability driven by ocean-atmosphere interactions. Archaeological and paleo-environmental records demonstrate that these constraints were persistent throughout the Nazca cultural sequence, shaping settlement patterns, subsistence strategies, and ritual behavior. Average annual rainfall in the Nazca Desert is typically less than 10 millimeters, with some years receiving no measurable precipitation at all. This extreme aridity results from the combined effects of the cold Humboldt Current, the subtropical atmospheric high-pressure system, and the rain shadow cast by the Andes. As a consequence, sustained agriculture was only possible in narrow river valleys fed by seasonal Andean runoff. Paleo-environmental studies provide insight into long-term climatic conditions. Sediment cores taken from coastal wetlands and alluvial fans indicate environmental stability punctuated by episodic disruption. Grain size variation and organic content suggest long intervals of hyperaridity interspersed with flood events linked to El Niño Southern Oscillation (ENSO) cycles. These oscillations introduced unpredictability into river discharge, alternately producing droughts and destructive flooding. Ice core data from Andean glaciers complement these findings. Records from high-altitude cores indicate shifts in precipitation patterns and temperature fluctuations during the late 1st millennium BCE and early 1st millennium CE. These data suggest that Nazca society developed under conditions of relative climatic stability but increasing variability over time. River dependency was absolute. The Nazca, Ingenio, and smaller seasonal rivers originated in the western Andean slopes, carrying meltwater and rainfall downslope to the desert plains. Archaeological surveys show that nearly all Nazca settlements were located within close proximity to these watercourses. Outside these corridors, permanent habitation was not viable. Radiocarbon dating of agricultural soils and irrigation features indicates that cultivation expanded gradually along these river valleys beginning before 100 BCE. Crops such as maize, beans, squash, and cotton were grown using canal-fed irrigation systems that redistributed seasonal flows. However, these systems remained vulnerable to fluctuations in water supply, reinforcing the precarious balance between environment and subsistence. After approximately 400 CE, multiple datasets indicate increasing climatic stress. Sediment layers show higher frequencies of flood deposits, while pollen records suggest shifts in vegetation consistent with changing moisture regimes. These environmental pressures coincide with archaeological evidence for reduced activity at ceremonial centers such as Kawachi, suggesting broader systemic strain. ENSO events appear to have intensified during this later period. El Niño phases brought episodic heavy rainfall to normally dry areas, damaging irrigation canals and agricultural fields. Conversely, La Niña phases reduced Andean precipitation, lowering river discharge and exacerbating drought conditions. Such oscillations would have challenged long-term planning and food security. The absence of large-scale water storage reservoirs further highlights environmental vulnerability. Unlike later Andean states, the Nazca did not construct centralized dams or lakes capable of buffering prolonged drought. Instead, they relied on managing existing flows through canals and subterranean systems, which required constant maintenance and cooperative labor. Archaeologists note that ritual responses to climatic uncertainty appear embedded within Nazca cultural practices. The concentration of geoglyphs and ceremonial activity near water sources suggests an ideological emphasis on fertility, renewal, and environmental balance. While causality cannot be directly proven, the temporal correlation between climatic stress and intensified ritual expression supports interpretations of adaptive cultural responses. Importantly, these environmental constraints did not lead immediately to collapse. For several centuries, Nazca communities successfully negotiated their ecological limits through localized adaptation and social coordination. However, the increasing frequency and intensity of climatic disruptions after the 5th century CE placed sustained pressure on these systems. These constraints demanded technological adaptation. As environmental variability intensified, the Nazca increasingly relied on engineered solutions and refined water management strategies to maintain agricultural production and social continuity. The Nazca engineered permanence in an impermanent climate. Faced with extreme aridity and variable river flows, the Nazca developed hydraulic systems known as puquios to secure a reliable water supply. These subterranean aqueducts exemplify technological adaptation to hyperarid conditions, demonstrating sophisticated knowledge of hydrology and soil mechanics long before the development of large-scale state societies in the Andes. Puquios consist of underground channels that tap aquifers fed by Andean rivers. Water was conveyed through sloping tunnels designed to maintain continuous flow while minimizing surface evaporation. Periodic spiral access shafts provided maintenance points, allowing workers to clear sediment, inspect channel integrity, and regulate water distribution. These shafts, often circular and carefully aligned, also functioned as ventilation points, preventing collapse within the tunnels. Dating evidence indicates that the earliest puquios appeared during the early Nazca period, around 100 BCE, with peak construction and maintenance activity occurring in the Middle Nazca phase, roughly 200 to 450 CE. Archaeological investigation, including radiocarbon analysis of wooden components and associated sediments, confirms that these systems were active for several centuries, highlighting long-term planning and investment. The engineering principles behind puquios were simple yet effective. Channels were constructed with slight gradients to maintain laminar flow, often following natural contours of the terrain. Spiral shafts allowed vertical access without interrupting horizontal flow. The use of local materials, stone lining, compacted soil, and occasionally wood reinforcements, demonstrates adaptation to available resources and understanding of structural stability in a shifting, arid substrate. Spatial distribution of pukios shows intentional placement relative to settlements and agricultural fields. Systems were typically located near cultivated terraces or river-fed valleys, providing consistent irrigation to maize, beans, cotton, and other staple crops. Hydraulic mapping indicates that water could be distributed equitably across multiple plots, reducing the risk of localized shortages. Maintenance of these systems required coordinated labor. Archaeologists infer that small teams worked collectively to remove silt, repair channel walls, and maintain access points. Seasonal rhythms of labor coincided with agricultural cycles, with periods of lower field activity dedicated to hydraulic upkeep. The organization of maintenance efforts parallels the cooperative structures inferred from geoglyph construction, suggesting continuity in social mobilization for communal infrastructure. The durability of the Pukio system contributed to long-term agricultural stability. Unlike surface canals, subterranean channels were protected from sedimentation, surface evaporation, and occasional flooding, allowing water to be stored and conveyed efficiently even during periods of irregular rainfall. This reliability mitigated the risks imposed by ENSO-related variability and prolonged dry seasons. Comparative studies suggest that pukios were unique among contemporary Andean hydraulic technologies. While later societies constructed large reservoirs and open canals, the Nazca solution emphasized minimal exposure, passive flow, and community-based maintenance. Archaeologists note that the system's efficiency relied less on mechanical innovation than on precise understanding of hydrological gradients and sustainable labor organization. The construction of pukios also illustrates the integration of technological and ritual considerations. Channels frequently occur near ceremonial sites, plazas, or geoglyph pathways, implying that water management and religious practice were spatially and conceptually interconnected. Water, in this context, was both a material necessity and a symbolic resource, reinforcing cosmological frameworks that emphasized fertility, renewal, and environmental stewardship. Evidence of ongoing maintenance into the late Nazca phase indicates the social importance of hydraulic systems. Channels were repaired, expanded, and monitored over generations, reflecting institutional knowledge transmission without reliance on centralized authority. This continuity underscores the ability of dispersed communities to coordinate effectively in response to environmental imperatives. Water control supported agricultural stability, allowing the Nazca to cultivate crops reliably despite arid conditions and climatic variability. By channeling subterranean aquifers through engineered tunnels, they transformed a precarious environment into one capable of sustaining population centers, ceremonial activity, and ritualized landscape modification. The pukios thus stand as enduring evidence of practical ingenuity interwoven with broader social and religious life. The first explanations looked to the sky. In the mid-20th century, researchers seeking to understand the purpose of the Nazca Lines proposed that their orientations corresponded to astronomical phenomena. Paul Kosak, an American historian investigating irrigation and settlement patterns in southern Peru, was among the earliest to systematically document these alignments. While conducting aerial surveys in the late 1930s and early 1940s, Kosak observed that some straight lines appeared to point toward the horizon at positions of the winter solstice sunrise and sunset. Kosak recorded hundreds of lines and trapezoids, noting repeated convergence on specific points along the desert skyline. He argued that these directional consistencies suggested deliberate planning to mark solar events. Kosak's observations were initially published in preliminary reports in the 1940s and later formalized in his 1941 article on the Nazca Desert, which emphasized the potential calendrical function of the lines. He specifically highlighted intersections of long lines with key solar azimuths. Building on Kosak's work, Maria Reich began extensive field measurements and mapping in the 1940s and 1950s. Reich utilized aerial photographs and ground surveys to measure line lengths, widths, and orientations with greater precision. She cataloged hundreds of geoglyphs, including linear, trapezoidal, and biomorphic forms, and attempted to correlate them with solar and stellar events. Reich's methodology included establishing reference markers on ridges and horizon points to determine angular alignment with the solstices and select constellations. Reich documented that some lines aligned with points of astronomical significance, such as the rising or setting positions of the sun during solstices. She also examined potential stellar connections, measuring line directions relative to prominent stars observed from Nazca Valley locations. Her work generated detailed maps, tables of azimuth measurements, and comparative diagrams linking geoglyph orientation with solar and stellar positions. Kossak and Reich also considered the spatial distribution of geoglyphs relative to topography. Hills, ridges, and valley edges were noted as consistent reference points, possibly used to cite astronomical alignments. Measurements of line azimuths in relation to these features were recorded for multiple geoglyph clusters, allowing repeated verification across different survey periods. Both researchers emphasized the precision and scale of the Nazca Lines. Long lines extending several kilometers maintained consistent width and straightness, supporting the possibility of intentional alignment. They observed that trapezoids and converging lines were often positioned in patterns that could be measured from a single observation point, suggesting planning consistent with alignment hypotheses. Reich conducted longitudinal observations over multiple seasons to confirm the relative accuracy of line orientations in relation to solar events. She documented seasonal changes in shadows and sun positions and compared these with the angles of selected geoglyphs. Kossak similarly recorded field notes noting the correlation of line azimuths with solstitial positions on the horizon, as seen from ceremonial areas near Kawachi. Aerial photography played a central role in these studies. Photographs taken from light aircraft provided comprehensive views of geoglyph networks, allowing researchers to identify patterns that were not apparent at ground level. High-resolution images enabled precise measurement of line lengths, intersections, and alignments, forming the basis for early astronomical analyses. Both Kossak and Reich published extensive records including diagrams, site maps, and photographic plates to document their hypotheses. Their work established a foundation for systematic measurement, mapping, and quantitative evaluation of geoglyph orientation, creating datasets that could be referenced by subsequent researchers. The combination of aerial surveys, ground measurement, and horizon observation represented a methodological advance in Nazca research. By quantifying line directions, lengths, and intersections, Kossak and Reich created the first comprehensive corpus of data suitable for comparative analysis with astronomical events. Water, not stars, dominates Nazca symbolism. Following the early astronomical hypotheses, researchers increasingly noted the prominence of water-related motifs within Nazca iconography and their potential connection to geoglyph placement. Ceramic vessels, textiles, and painted imagery frequently depict water, rain, serpents, and amphibious creatures, suggesting that fertility and water management were central concerns of Nazca society. Many biomorphic geoglyphs correspond to animals and symbols associated with water and agricultural fertility. The depiction of spiders, herons, and pelicans, for example, aligns with creatures connected to riverine and coastal ecosystems. These representations occur alongside trapezoidal and linear forms, which may have functioned as ritual pathways, possibly intended for processions linked to rainmaking ceremonies or fertility rites. Archaeological correlations indicate that geoglyphs are often situated near water sources or along routes leading from settlements to riverbeds and irrigation infrastructure. The proximity to these resources suggests intentional integration of geoglyphs within a broader water management and ritual landscape. Some lines appear to converge on subterranean aquifer sites tapped by pukios, further linking geoglyph activity with hydrological resources. Ceramic evidence reinforces these interpretations. Recovered vessels frequently portray scenes of ritual offering, water-bearing deities, and ceremonial practices associated with agricultural cycles. Such artifacts provide temporal markers, placing the peak of water-related symbolism between 200 and 450 CE, concurrent with the Middle Nazca phase of geoglyph construction. Ethnographic comparisons with later Andean societies provide additional context. Colonial-era accounts describe ritual practices directed toward water deities and sacred springs, often involving communal processions, offerings, and symbolic enactment of rainfall ceremonies. These parallels support the inference that Nazca rituals integrated landscape modification, movement, and water symbolism as part of a coordinated religious system. Field studies reveal that certain trapezoidal formations and long linear pathways may have functioned as ceremonial channels, guiding participants along processional routes toward key water points or ritual centers such as Kawachi, where patterns and line widths indicate repeated use, suggesting sustained participation in movement-based ceremonies rather than ephemeral markings. Iconography also emphasizes transformation and reciprocity. Anthropomorphic figures combined with water-associated animals appear on ceramics and textiles, indicating conceptual links between human actors and the natural environment. This thematic integration supports interpretations that geoglyph creation, maintenance, and ritual procession were intertwined with environmental management and symbolic enactment of fertility. The distribution of geoglyphs across the desert plain further demonstrates functional diversity. While some lines appear isolated, others form networks radiating toward valleys, hills, or aquifer sites. This spatial arrangement reflects deliberate planning to situate symbolic activity within zones of environmental significance, reinforcing the connection between ritual performance and the material landscape. Chronological evidence indicates that water-related interpretations coincide with a period of intensive agricultural activity. Soil analyses, irrigation construction dating, and canal maintenance records show that the Middle Nazca phase saw coordinated efforts to stabilize food production under conditions of climatic stress. Ritualized landscape modification, including geoglyph creation, may therefore have served as a complementary strategy, linking practical resource management with religious practice. Scholars have also documented offerings associated with geoglyphs and ceremonial centers, including miniature ceramics, food remnants, and textile fragments. These deposits suggest structured, repeated participation by community members in ritual activity, often tied to water or fertility themes. The combination of material evidence, spatial patterns, and ethnographic analogies provides a multidimensional framework for understanding geoglyph function beyond purely visual or astronomical purposes. Water cult interpretations do not exclude the use of geoglyphs for orientation or symbolic representation. Rather, they highlight a primary thematic concern within Nazca religious practice, reflecting the centrality of water to survival, agriculture, and social cohesion. Geoglyphs appear as integral elements within a landscape engineered both materially and ritually to address environmental and spiritual needs. Function likely extended beyond symbolism alone. The integration of geoglyphs with processional pathways, settlement zones, irrigation systems, and ceremonial centers underscores the practical and ceremonial dimensions of Nazca ritual life, situating the lines as active components of an adaptive cultural system oriented around fertility, water access, and communal participation. At its height, Nazca society remained decentralized. During the Middle Nazca phase, approximately 200 to 450 CE, the population of the southern Peruvian coast reached its densest concentration, while cultural cohesion and ceremonial activity were at their peak. Archaeological surveys of the Nazca and Ingenio river valleys reveal a settlement pattern characterized by dispersed villages and kin-based residential compounds rather than centralized urban centers or administrative capitals. Excavated compounds generally consist of clusters of rectangular adobe structures surrounding small courtyards. These units appear to have housed extended family groups, with spatial organization reflecting kinship ties rather than hierarchical political control. Household plots were often positioned in close proximity to irrigated agricultural fields, terraces, and puccio systems, demonstrating integration of residential, economic, and environmental planning at the local scale. Residential clusters exhibit material uniformity. Differences in house size, ceramic assemblages, or textile quality are minimal across surveyed sites, indicating relative socio-economic parity among households. Archaeologists note the absence of elite residences or specialized administrative buildings, reinforcing interpretations of a society structured around cooperative, rather than coercive mechanisms of social organization. Defensive architecture is notably absent from Middle Nazca settlements. Unlike contemporaneous Andean societies with walled compounds or fortified centers, The Nazca did not construct barriers to defend against intercommunity conflict. This suggests that warfare, while not necessarily non-existent, was limited and did not dominate settlement decisions or regional planning. Instead, social integration appears to have relied on shared ritual practice, kinship networks, and reciprocal labor arrangements. Kawachi, located near the Nazca River, functioned as the primary ceremonial center during this period. Excavations reveal a large, complex assemblage of plazas, mounds, and ritual deposits, but little evidence of permanent residential occupation. The ceremonial center was spatially and functionally separate from villages, emphasizing that religious activity, rather than centralized political administration, underpinned regional cohesion. Settlement layout also reflects environmental constraints. Villages are positioned along river valleys where seasonal flows could be channeled through canals and pukios, ensuring reliable access to irrigation for domestic and agricultural use. Proximity to arable land, water infrastructure, and ceremonial sites suggests deliberate placement to integrate practical subsistence with ritual participation. The pattern of dispersed villages implies that regional coordination was maintained through networks of ceremonial activity rather than formal governance. Pilgrimage routes, geoglyph pathways, and shared ceremonial schedules likely reinforced social cohesion across valley communities. This decentralized arrangement allowed communities to manage local resources autonomously while participating in collective religious practice. Specialized craft production developed within this settlement framework. Evidence from residential compounds shows areas designated for ceramic manufacture, textile weaving, and ritual artifact preparation. Artifacts produced in these local workshops were likely circulated within the broader regional network, connecting dispersed villages through material culture and shared symbolic systems. The absence of centralized production centers indicates that craft specialization emerged organically within kin-based social units rather than through institutional oversight. Regional organization during this period also exhibits adaptive strategies to environmental variability. Dispersed villages minimize pressure on localized water and soil resources, while cooperative labor networks facilitated maintenance of irrigation canals, pukios, and agricultural terraces. This spatial configuration supported both subsistence security and ritual obligations, linking practical and ceremonial aspects of daily life. Chronologically, the Middle Nazca phase represents a period of maximal cultural expression. The distribution of geoglyphs, ceremonial deposits, and ritual architecture aligns with the spatial organization of villages, indicating integrated social, religious, and environmental systems. Settlement archaeology demonstrates that the Nazca achieved a high degree of regional coordination without centralized political authority, relying instead on kinship, cooperative labor, and shared ritual frameworks. This settlement structure supported specialized craft production. By combining environmental adaptation, dispersed habitation, and ceremonial integration, Nazca society maintained cohesion, productivity, and ritual vitality across the southern desert valleys, establishing a social system capable of sustaining complex cultural expression in a challenging environment. Art was a unifying language across Nazca society. During the Middle Nazca phase, approximately 200 to 450 CE, communities across the southern desert valleys developed highly standardized systems of ceramic, textile, and metal production. These crafts not only fulfilled practical functions but also reinforced shared religious symbolism and regional cultural cohesion. Ceramic production was particularly advanced. Polychrome vessels display precise firing techniques that allowed for vibrant reds, oranges, yellows, and blacks to remain stable under high temperatures. Archaeological evidence indicates the use of carefully controlled kiln atmospheres and multiple firing stages, demonstrating substantial technical knowledge. Stylistic analysis reveals consistent application of motifs, including anthropomorphic figures, animals associated with water and fertility, and abstract geometric patterns. These images parallel those found on geoglyphs, suggesting coordinated symbolic language across material forms. Excavations of workshop areas near residential compounds indicate localized production rather than centralized manufacture. Kilns, clay preparation pits, and shaping tools were distributed among village clusters, allowing households or kin groups to produce ceramics for both domestic and ceremonial purposes. This pattern shows specialization emerging within communal networks rather than under elite control. Finished vessels were likely exchanged between neighboring settlements, enabling widespread distribution of standardized forms. Textile production demonstrates both continuity and technical innovation. Weaving methods, such as twining and brocading, retain elements traced to earlier Paracas traditions, including the use of cotton and camelid fibers and complex decorative patterns. Excavated fragments indicate that dyestuffs were carefully prepared to achieve color-fast results, and that designs consistently incorporated motifs from religious and natural iconography. Textile workshops, like ceramic production zones, were often household-based, highlighting the integration of craft specialization into daily domestic activity. Metallurgy, though less extensively documented, also contributed to material culture. Small copper and gold artifacts, including pins, jewelry, and ritual objects, are found primarily in ceremonial contexts or elite burials, suggesting limited but technically proficient production. Evidence from smelting residues and casting molds indicates knowledge of alloying and controlled heating, sufficient to create durable and stylistically consistent objects. Together, ceramics, textiles, and metallurgy formed an interconnected system of craft specialization that reinforced social cohesion. Common motifs across media created a recognizable visual vocabulary that facilitated communication of religious, ritual, and communal identity. The repetition of certain forms and figures ensured that participants across dispersed settlements shared symbolic frameworks, aligning local practice with regional cultural norms. Chronologically, stylistic consistency in artistic production peaks between 300 and 500 CE, corresponding to the period of maximal geoglyph creation and ceremonial activity. Radiocarbon dating of kiln structures, ceramic sherds, and textile fragments demonstrates sustained production over multiple generations. This stability indicates that craft specialization was not episodic but integrated into the broader economic and ritual systems of Nazca society. Distribution patterns suggest access to broader exchange networks. Ceramics and textiles traveled along pathways connecting villages, ceremonial centers, and irrigation zones. Raw materials, including high-quality clay, plant fibers, and mineral pigments, were sourced from local and regional deposits, reflecting knowledge of environmental resources and logistical coordination. The circulation of finished products facilitated shared cultural expression across geographically dispersed communities. Workshops were embedded within household compounds, emphasizing that production was a social as well as technical process. Labor involved multiple participants, including men, women, and possibly adolescents, performing specialized tasks such as spinning, weaving, painting, or firing. This cooperative structure mirrored the collective organization observed in agricultural, hydraulic, and geoglyph-related activities, reinforcing patterns of communal labor and knowledge transmission. Craft specialization also intersected with ceremonial practice. Certain vessel types, textiles, and metal artifacts were produced explicitly for ritual use, including offerings at Kawachi and along geoglyph pathways. The replication of religious motifs across these media ensured consistency in ritual symbolism, providing visual continuity that reinforced social and spiritual cohesion throughout the region. Specialization depended on access to broader exchange networks. Villages could obtain raw materials, share technical knowledge, and distribute finished goods without requiring centralized administrative oversight. This decentralized system supported both economic efficiency and cultural unity, allowing Nazca society to maintain cohesive identity while remaining spatially dispersed. By linking technical proficiency, symbolic representation, and cooperative organization, Nazca craft production exemplifies the integration of material culture and social structure. Artistic output not only fulfilled practical needs but also functioned as a communicative medium, aligning households, villages, and ceremonial centers within a unified cultural framework that characterized Nazca society at its height. Environmental balance began to falter. After approximately 450 CE, paleoenvironmental records indicate that the Nazca region experienced increasing aridity combined with more frequent and intense El Niño, Southern Oscillation, ENSO, events. These climatic fluctuations destabilized river flows and disrupted established irrigation and agricultural systems, placing sustained pressure on the subsistence base that had previously supported both population growth and ceremonial activity. Sediment cores from the Nazca and Ingenio valleys reveal a higher frequency of flood deposits interspersed with extended dry periods. Analyses of grain size, mineral composition, and organic matter content demonstrate that river channels became more variable, alternating between low flow during La Nina phases and episodic inundation during strong El Niño events. These fluctuations complicated the management of water for both fields and residential use. Glacial ice core data from the high Andes corroborate local findings, showing reduced precipitation and increased temperature variability during this period. Together, these datasets suggest that previously predictable seasonal cycles became irregular, limiting the reliability of traditional agricultural strategies. Crops such as maize, beans, and cotton, dependent on stable irrigation, were increasingly vulnerable to periods of drought or excessive flooding. Archaeological evidence indicates that the resource stress had tangible effects on water management infrastructure. Excavations of Puquios show reduced maintenance in the later Middle Nazca and early Late Nazca phases. Spiral access shafts display sediment accumulation and partial collapse, while channel lining exhibits localized erosion. Canal networks feeding agricultural terraces similarly show signs of siltation and repair neglect, indicating diminished labor investment in hydraulic upkeep. Settlement patterns provide further insight into environmental pressures. Some smaller villages exhibit partial abandonment during this period, while remaining residential compounds cluster more tightly around dependable water sources. Survey data suggests that population redistribution was influenced by proximity to functional irrigation, emphasizing the centrality of water reliability in sustaining communities. Soil studies indicate declining fertility in certain cultivated areas, likely compounded by irregular flooding and reduced irrigation. Radiocarbon-dated botanical remains demonstrate that agricultural productivity fluctuated considerably, potentially limiting surplus storage and reducing the reliability of provisioning for ceremonial centers such as Kawachi. These constraints would have challenged the social structures that depended on coordinated labor and ritual participation. Environmental stress also intersected with mobility patterns. Geoglyph pathways and processional routes may have been used less consistently as access to ceremonial centers became constrained by reduced water availability. Where patterns along key lines show reduced traffic in some areas, suggesting that participation in regional ritual activities may have declined as resource pressures increased. The combination of aridity and ENSO-related disruption represents a systemic challenge. Agricultural, hydraulic, and settlement systems were closely interdependent. Failure in one sector could propagate across others. Reduced maintenance of irrigation infrastructure, localized crop failures, and shifting settlement occupancy collectively undermined the material foundation for social and ceremonial cohesion. Chronologically, this period coincides with the early Late Nazca phase, roughly 450 to 600 CE. Radiocarbon dating of irrigation features, habitation layers, and ceremonial deposits indicates that these environmental changes had sustained impact over several generations. Archaeological sequences show gradual modification of settlement layouts and adaptation of agricultural strategies in response to variable water availability. The effects of climatic deterioration were magnified by the Nazca reliance on narrow river valleys. With limited rainfall and high dependence on controlled flow from Andean sources, communities had minimal buffer capacity. Unlike later Andean states capable of constructing large reservoirs or multi-village hydraulic systems, the Nazca maintained smaller-scale, decentralized irrigation networks, which were inherently vulnerable to environmental instability. These developments mark the beginning of a period in which scarcity reshaped social behavior. Labor allocation, ritual participation, and communal cooperation were increasingly constrained by the availability of water and agricultural resources. The reliability of previously integrated systems, puquios, terraces, ceremonial infrastructure, declined, setting the stage for broader cultural transformation during the later phases of Nazca society. Ritual violence intensified as stability declined. Archaeological and osteological evidence indicates that during the late Nazca phase, roughly 450 to 600 CE, communities experienced heightened social tension, which manifested in increased instances of trauma, defensive settlement planning, and ritualized forms of violence. While the Nazca did not develop large-scale warfare typical of highland Andean states, local stress appears to have contributed to a marked intensification of competitive and symbolic aggression. Skeletal analyses provide direct evidence of interpersonal trauma. Excavations in burial sites across the Nazca and Ingenio valleys reveal cranial fractures, sharp force injuries, and healed wounds consistent with sustained conflict. Patterns of trauma are often localized to adult males, suggesting targeted aggression within or between communities. Some injuries, including those consistent with stabbing or slashing weapons, appear to have been inflicted in controlled ritual contexts rather than open battlefield conditions. Fortified or defensible features emerge in late Nazca settlements. While middle Nazca villages lacked protective architecture, later habitation clusters occasionally include elevated platforms, perimeter walls, or restricted access points. These modifications indicate an increased concern for security, possibly reflecting rising competition over limited water, agricultural land, or ritual access during periods of environmental stress. Trophy head production intensified during this period. Decorated skulls recovered from ceremonial caches display perforations, pigment application, and cord attachments, suggesting ritual use rather than utilitarian consumption. The frequency and distribution of these artifacts increase in the late Nazca phase, implying that such practices were socially sanctioned and perhaps intended to assert status, enforce ritual norms, or symbolically regulate conflict among communities. Archaeological context indicates that ritualized violence was embedded within ceremonial frameworks. Trophy head caches are often associated with plazas, mounds, or geoglyph pathways, linking acts of aggression to sacred spaces rather than domestic settings. This placement reinforces the interpretation of violence as symbolic, coordinated, and socially mediated, rather than opportunistic or purely combative. Settlement patterns also suggest strategic adjustment to heightened tension. Dispersed villages consolidate near reliable water sources, terraces, and defensible topography. Narrowed access points to fields, clustering of compounds, and proximity to ceremonial centers all suggest that social groups were reorganizing spatially in response to perceived threats or competitive pressures. These patterns align with observations of increased trauma and ritualized aggression. Ceramic and textile evidence supports these interpretations. Imagery appearing on vessels and woven artifacts from this period depicts anthropomorphic figures engaged in ceremonial combat or processions carrying severed heads. Such iconography is concentrated in late Nazca assemblages, providing corroborative material culture evidence for socially regulated violence and heightened symbolic competition during times of resource stress. Ethnographic parallels from later Andean societies illustrate how ritualized aggression can function as a mechanism to manage social tension. In several highland and coastal traditions, ceremonial combat, symbolic head-taking, or staged confrontations provided structured outlets for disputes, maintained social cohesion, and reinforced cosmological hierarchies. Although direct equivalence cannot be assumed, these analogies support the interpretation of increased Nazca violence as controlled, culturally embedded practice. The intensification of ritualized violence coincides with environmental deterioration. Reduced reliability of water sources, disrupted agricultural production, and declining maintenance of irrigation infrastructure created pressures on subsistence and labor coordination. In this context, socially sanctioned displays of aggression may have functioned as mechanisms to regulate competition over scarce resources, enforce group identity, or reaffirm ritual authority. Chronologically, evidence indicates that these patterns peaked between 500 and 600 CE. Skeletal trauma, fortified settlements, and trophy head deposition are more pronounced in this interval compared with preceding Middle Nazca phases. Radiocarbon dates from associated contexts confirm simultaneous environmental stress, linking climatic deterioration with observed increases in social tension and ritualized violence. Importantly, while the prevalence of trauma and fortifications increased, large-scale warfare remains largely absent. Nazca communities appear to have avoided the formation of standing armies or expansive territorial conquest. Instead, competitive behavior was ritualized, localized, and integrated with ceremonial activity, reflecting a social system adapted to stress without developing high-intensity armed conflict. Ritual responses intensified alongside conflict. The combination of ceremonial violence, settlement consolidation, and strategic resource management illustrates how Nazca society responded to environmental and demographic pressures. Symbolic and controlled forms of aggression coexisted with agricultural and hydraulic adaptations, demonstrating the interplay of ecological stress, social behavior, and ritual expression in shaping late Nazca cultural transformation. The ceremonial heart of Nazca fell silent. Between approximately 500 and 600 CE, the primary ritual center of Kawachi experienced a gradual decline in occupation and activity. Archaeological surveys reveal that the extensive plazas, mounds, and ceremonial platforms were increasingly neglected, and the accumulation of ritual deposits slowed. The pattern of abandonment was gradual rather than sudden, indicating that this transition resulted from cumulative environmental and social pressures rather than catastrophic events. Evidence points to environmental stress as a central factor in the decline. Increased aridity, irregular river flows, and intensified El Niño, southern oscillation events, disrupted the agricultural base that had supported both population and ritual activity. Sediment analysis from the Nazca and Ingenio valleys shows flood layers that damage terraces and canals, while pollen studies indicate reduced agricultural productivity. As a consequence, communities that relied on Kawachi for periodic ceremonial gatherings faced logistical challenges in provisioning pilgrims and maintaining infrastructure. Archaeological features of the site reflect this gradual disengagement. Maintenance of mounds and plazas decreased, with some structures showing evidence of partial collapse or sediment accumulation. Puquios and associated irrigation features in surrounding valleys show reduced upkeep, suggesting that labor previously mobilized for ceremonial support was redirected toward subsistence and local community needs. Excavations indicate that ceremonial areas remained physically intact but were less frequently used, as seen in the diminishing frequency of offerings and artifact deposition. Patterns of material culture also reflect reduced activity. Fewer high-quality ceramics and textiles are deposited within ceremonial contexts during the late Nazca phase. Radiocarbon dating of organic materials indicates that ritual use of Kawachi became intermittent, with peak activity during earlier Middle Nazca phases. There is no archaeological evidence for widespread destruction, looting, or abandonment due to violent incursion, confirming that the decline was driven primarily by environmental and social factors. Pilgrimage and movement within the ritual landscape diminished accordingly. Where patterns along geoglyph pathways leading to Kawachi show reduced foot traffic, consistent with the decreasing role of the center in regional ceremonial practice. Smaller, localized ritual activities may have continued in surrounding villages, but the scale and centralization of Middle Nazca ceremonial life were no longer sustainable. Chronologically, the abandonment aligns with broader shifts in settlement and social organization. Dispersed villages experienced population redistribution, with some communities consolidating around reliable water sources, while others were partially or fully vacated. The combination of reduced agricultural output, environmental instability, and logistical difficulty in sustaining large ceremonial gatherings contributed to the decline of Kawachi as a regional focal point. The archaeological record also suggests that cultural memory of Kawachi persisted despite declining use. Artifacts and architectural elements were occasionally maintained or modified in later phases, indicating that the site retained symbolic significance even as practical and ritual functions diminished. This continuity supports interpretations of gradual transformation rather than abrupt collapse. The decline of Kawachi reshaped regional dynamics. With the central ceremonial hub losing its role as a unifying locus, dispersed villages and emerging secondary centers assumed greater prominence in local ritual and social coordination. Water management systems, residential organization, and craft production adapted to these changing patterns, reflecting a shift toward more localized governance and communal autonomy. In summary, the abandonment of Kawachi illustrates a measured cultural transition rather than catastrophic collapse. Environmental pressures, reduced pilgrimage, and declining agricultural productivity combined to reduce the functional role of the ceremonial center. Yet the absence of violent destruction, continued symbolic engagement, and adaptive responses across surrounding communities underscore the complex, gradual nature of Nazca societal transformation during the 6th century CE. The lines outlived the society that made them. Following the decline of Nazca ceremonial and residential centers by approximately 600 CE, the geoglyphs persisted as prominent features of the southern desert landscape, yet there is no evidence that subsequent populations actively maintained or created new figures. Archaeological and ethnographic records suggest that later Andean communities recognized the presence of the lines, but their function shifted from active ritual participation to passive visibility within the landscape. Excavations and survey data show that post-Nazca societies occupied portions of the Nazca and Ingenio valleys without directly engaging in geoglyph construction. Ceramic styles, textiles, and settlement patterns indicate continuity in local occupation, but material culture does not exhibit the distinctive iconography or spatial organization associated with Middle and Late Nazca ceremonial activity. Radiocarbon dating confirms a cessation of large-scale geoglyph creation after the 6th century CE. Despite this, the geoglyphs retained symbolic prominence in the cultural memory of later groups. Colonial-era accounts, collected centuries after Nazca society had transformed, describe indigenous awareness of enigmatic lines and figures, suggesting that the landscape continued to carry cultural significance. In some cases, ritual or ceremonial references to water, fertility, and sacred sites indicate that symbolic association with the desert persisted, even in the absence of active line maintenance. Material continuity is also observed in the broader ritual landscape. Later communities maintained settlement proximity to perennial water sources, terraces, and small ceremonial platforms, reflecting inherited practices of environmental adaptation and ritual orientation. The geoglyphs, while no longer functionally integrated into ritual activity, remained embedded within these spatial frameworks, providing enduring markers of past cultural organization and cosmological symbolism. The absence of new construction underscores the distinction between legacy and continuity. While the Nazca Lines continued to shape the perceptual and symbolic environment, subsequent societies did not replicate the labor-intensive production methods or coordinated ceremonial practices that had characterized the Middle Nazca phase. This distinction is critical for understanding the lines as a historical artifact rather than a living tradition carried forward by later populations. Ethnographic analogies support this interpretation. Accounts of later Andean ritual sites suggest reverence for ancestral landscapes, including ancient terraces, mounds, and sacred waterways, without replication of specific iconographic forms. These parallels indicate that the Nazca Lines were integrated into cultural memory as enduring markers, rather than as active elements in ongoing ceremonial performance. The persistence of visibility contributed to both historical and modern recognition. The geoglyph scale, permanence, and alignment with natural features ensured that they remained recognizable over centuries, even under desert conditions. Wind patterns, minimal rainfall, and protective desert pavements preserved the lines, allowing successive populations to encounter them without substantial degradation. Chronologically, the post-Nazca phase extends from approximately 600 CE through the late pre-Columbian period, when regional polities such as the Wari and later Inca began to exert influence along the southern coast. While these external societies incorporated parts of the Nazca territory into broader administrative and ceremonial networks, there is no indication that they engaged in geoglyph construction or maintenance, reinforcing the interpretation of the lines as historical relics rather than active ritual features. This enduring visibility laid the foundation for modern engagement. The geoglyph's persistence in the landscape provided the material basis for recognition by colonial observers, early travelers, and 20th century researchers. Archaeologists and historians would later rely on this continuity of form to reconstruct Middle and Late Nazca social organization, ritual practice, and environmental adaptation. In sum, the post-Nazca cultural memory of the lines demonstrates a clear distinction between physical persistence and active cultural use. Subsequent populations recognized and navigated a landscape shaped by their predecessors, maintaining settlement continuity and ritual orientation while refraining from direct line construction. The Nazca Lines remained enduring markers of past society, preserving the imprint of a complex cultural system long after the decline of the civilization that created them, and establishing a tangible link between the ancient and modern understanding of the Nazca Desert. Preservation became the modern challenge. Although the Nazca Lines had persisted for centuries, their global recognition and systematic study did not occur until the 20th century. Aerial observation in the 1920s and 1930s, along with the pioneering work of Toribio Mejia Zesp and Paul Kosak, revealed the scale and complexity of the geoglyphs. Maria Reich's decades-long survey, mapping, and protective efforts established the foundations of modern preservation practices, emphasizing accurate documentation, site monitoring, and public awareness. Formal protection intensified following UNESCO's designation of the Nazca Lines as a World Heritage Site in 1994. This recognition underscored the international importance of the geoglyphs, not only as archaeological artifacts but as evidence of pre-Columbian societal organization, ritual practice, and environmental adaptation. Conservation protocols included restrictions on vehicular access, controlled observation platforms, and monitoring programs to track erosion, human encroachment, and other potential damage. Despite these measures, the Nazca Lines face persistent threats. Urban expansion, road construction, and unregulated tourism have periodically encroached on the geoglyphs. Archaeological reports document instances of road-related damage and inadvertent destruction of peripheral figures. Mining exploration and agricultural development further increase risk, particularly in regions adjacent to previously protected areas. Satellite imagery and on-the-ground surveys indicate that unauthorized activity can quickly compromise the line's integrity, necessitating ongoing vigilance. Climate and environmental factors remain relevant. Although the hyperarid conditions of the Nazca Desert continue to protect much of the geoglyph surface, episodic rainfall, wind erosion, and sediment deposition gradually alter lines and trapezoids. Conservation planning incorporates geomorphological studies and remote sensing to anticipate potential degradation, integrating both natural and anthropogenic considerations into preservation strategies. Community engagement and education are central to sustainable management. Programs involving local populations aim to reinforce awareness of the geoglyph's cultural significance while promoting responsible tourism. Interpretive centers, restricted access paths, and public information campaigns help balance heritage protection with economic opportunities for surrounding communities, ensuring that preservation is both socially and environmentally informed. Monitoring and research remain integral. Archaeologists employ high-resolution mapping, drones, and GIS analysis to track changes in line integrity over time. These tools allow precise documentation of subtle shifts, erosion patterns, and emerging threats, facilitating evidence-based intervention without unnecessary disruption to the site. The integration of scientific research with heritage management exemplifies a modern approach to preservation grounded in both ethics and empirical observation. Legal frameworks complement these technical efforts. National regulations in Peru, reinforced by UNESCO guidelines, provide mechanisms for prosecution in cases of deliberate damage and delineate protected zones around the lines and associated ceremonial sites. Coordination between governmental agencies, researchers, and local authorities has created a multi-tiered system designed to address both immediate risks and long-term conservation goals. Chronologically, the 20th and 21st centuries represent a distinct phase in the Nazca Lines' history, one in which cultural significance is recognized beyond its original social and ritual context. Whereas the lines were once integrated into community practice, modern engagement frames them as global heritage requiring careful stewardship. Preservation, therefore, is both a scientific and ethical enterprise, balancing access, study, and protection. Current challenges highlight the dynamic nature of cultural heritage. Urban growth, infrastructure development, and environmental pressures continuously test management strategies, demonstrating that preservation is not a static achievement but an ongoing process. Adaptive strategies, informed by archaeological evidence and risk assessment, remain essential to maintaining the integrity of the geoglyphs for future research and public understanding. In conclusion, the rediscovery and preservation of the Nazca Lines illustrate the evolving relationship between past and present. From early aerial surveys to UNESCO designation and contemporary conservation programs, These efforts underscore the necessity of protecting material culture within both environmental and societal contexts. Preservation is inseparable from ethical stewardship, scientific documentation, and community involvement, ensuring that the lines continue to inform scholarly interpretation and global awareness while maintaining their physical and cultural integrity. Before you go, make sure to subscribe to Nightfall History for daily deep dives into the past. Click the bell icon to be notified of new videos, and leave a comment sharing which aspect of the Nazca civilization fascinated you the most. Your engagement helps keep history alive and allows us to continue bringing these ancient stories to life.